Okay, today we will be going over area and perimeter. This is the GED formula sheet. We've already gone over it for quite some time now, and we are finally going to dive into the top section of the formula sheet. We have been dealing with everything down here below. We've already gone over slope of a line, y equals mx plus b. I kind of briefly went over point slope form. We went over the quadratic equation section. We went over Pythagorean theorem. This bottom section we have not gone over, which is totally fine because it involves more with the basics, right? I don't think I ever told you this, but it does include a little bit of the definitions of mean and median. Go look at the mean, median, mode, and range lesson to go over how you deal with mean and median and mode and range. But now we get to deal with this section, the geometry section, right? We are going to be dealing with shapes. In particular, in today's lesson, we will be dealing with area and perimeter. Now, if you feel like you know what area and perimeter is, which you probably do, I still recommend watching this video because chances are you only know the basics of area and perimeter. You don't necessarily know the way the GED is going to throw the questions at you, nor do you know the certain tricks that they try to trick you with. So, area and perimeter, what does it mean and what are you dealing with when it comes into area and perimeter? You only deal with a couple shapes when dealing with area and perimeter. So, there's this 2D world and there's this 3D world, okay? In the 2D world, two-dimensional, there's obviously a couple two-dimensional shapes that we will be dealing with in the GED, and you probably know the basics like a square, a rectangle, triangle, circle. Other shapes that you need to master is the trapezoid, which, by the way, both of these are trapezoids. Sometimes you'll have one where the two sides are angled and slanted, I should say, or a trapezoid in which only one side is slanted but the other one is straight. No tricks there. They're both still trapezoids, right? The other shape you're going to deal with is the parallelogram, which is just a rectangle that got blown by the wind a bit and it got skewed a little bit, right? So these are the two-dimensional shapes that we're going to be dealing with, specifically with area and perimeter. In the three-dimensional world, that's the next lesson. There are three-dimensional shapes in which you see all sides of a figure, and then we don't really deal with area and perimeter there. We deal with volume and surface area. Just giving you a heads up on what's to come for the next lesson. But this is our realm today. We will be dealing with these two-dimensional figures. Why did I go over this? Is because that's your first lesson. You need to memorize these shapes. Like I said, some of these shapes you probably already know, but you should know how a trapezoid looks and what a parallelogram looks like from this point forward. So these two-dimensional shapes, like I said, you can be given some on the GED and you'll be asked to find the area or asked to find the perimeter. You'd be lucky actually if they ask it to you like that. Most likely they'll ask it in a word problem. Now, that's the second lesson of the day. How is it going to sound like in the GED? If they were to give you this right here, let's say they say this is this is an aerial view of Neil's yard, and it measures 20 feet by 40 feet, even though it doesn't look that big of a difference. It looks like a square, but they give you this, and they say this is your yardage, Neil's yardage, 20 feet, 40 feet. And then they ask, Neil's trying to look for the amount of feet of fencing he needs to go around his yard. And then they expect you to find it. They never at one point asked you to find the area, asked the perimeter. They asked it to you in word problem style. It's up to you to know that in that question they're asking you to find the perimeter. It's because they said around the yard. That means perimeter. So perimeter, what perimeter means is just the outside measurement. All right, if you were to measure from here to there, whatever that measurement is, plus whatever this measurement is, which is 20, plus whatever this measurement is, which is 40, plus that measurement, it is the perimeter. It's only the outside. So be aware of when they try to trick you by asking you word problems like that, because they won't ask you what's the perimeter. They'll ask you how much fencing does Neil need, right? If they were to say how much synthetic grass must he buy to roll onto his yard, because he wants to fill the whole yard with fake grass, they are asking for the area there. Area means the inside measurement. It means the square footage or whatever you want to call it, the inside measurement of the inside of the figure, okay? So with these two-dimensional shapes that you see here, when they ask you questions like that, how much water does the pool fill? How much does the roof, how much roofing material do you need? Whatever it is they try to ask, when they ask you questions that are along the lines of what's the inside measurement or what's the outside, they're asking you for area and perimeter, okay? So now comes the question, now that you have that second lesson out of the way, now comes this third lesson. How do you find the area and perimeter? So we're going to stick with the perimeter first. Here's the thing. Perimeter, I kind of went over it already. It's the outside. So all you need to do is add the outside. In your formula sheets, you do have a perimeter section, okay? Now, we're going to deal with the circle in a bit. But for right now, all these other shapes with their fancy little formulas, you don't even really need it. Because I just told you the trick to find the perimeter of any shape besides the circle. Let's just wait off on that. But all these other shapes, you can find the perimeter by adding all the outside sides. All right, so let's look at a trapezoid just for fun. If we were to draw a trapezoid. By the way, going back to this shape, what would be the perimeter? Like I said, adding all the outsides. So 20 plus 40. It's up to you to know that this is your 20, this is your 40. So it's 20, 40, which is 60, plus another 60, and that's 120 for your perimeter. Perimeter equals 120. Let's say they gave us some measurements here. Now, the trapezoid, they might display it like this. 10, 12, 11... 16, right? They might give you something like this. And I ask you to find the perimeter. It is just adding all the outsides. This 10 here is symbolizing the height of the trapezoid, which, by the way, hint, hint, is going to be used to find the area. That's why they give it there, right? But if they asked for the perimeter, this 10 doesn't mean nothing to us, because to find the perimeter, all we need to do is add all the sides from the outside. So you got to add this 12 plus this 11 plus, if you don't see in these type of examples, if you don't see a number, you got to know it's the same as the opposite side. It's 12, right? And then plus your 16, and that would give you your perimeter. What would that be? All you got to do is, again, use your fingers. Try to do it by hand, or your trusty little calculator is just throwing everything in. Do not ever hesitate to whip out that calculator and let the calculator do the math for you. So, do we get that? Perimeter, add up all your outsides. Easy peasy. Area. That, my friends, is where your best friend, the formula sheet, comes into play. We have this little section here at the top with formulas. Okay. If you see here, how do you find the area of a square? Well, there's its formula to find the area. How do you find the rectangle? There it is. How do you find a parallelogram? There it is. You have your cheat sheet there, my friends. You can easily just refer to the formula sheet. So if we look here, this is a, let's stick with the trapezoid. You must follow these techniques. When they ask you to find the area or perimeter in whatever fancy way they're asking you, you got to know what shape is in front of you. Okay, we have a trapezoid. So what you then do is you go, and depending on what they're asking you to look for, in this case the area, you must go to that shape's name and write out the formula. So I'm going to get this formula and I'm going to write it out. It's helpful, trust me, to just write it out. You might think it's a tedious process. You could just look at the formula sheet and then try to calculate it, but it helps to write it out. It was 1/2 height base 1 plus base 2. I memorized it, right? And then what it helps, just like every other formula we've dealt with before, the same thing we've been doing for so long since evaluating expressions, is we are going to substitute all the letters with parentheses and then dump in the number of what those variables are. So that's pretty straightforward. We've been doing that. The thing is, in geometry, we're dealing with a lot more variables within our formulas. Variables that you need to know what means what, right? So the h is a new variable for you. What do you think that would mean, though, using common sense? It means height, right? So, oh yeah, duh. You got to substitute everything in parentheses first. Trust me, it'll help you. And then dump in the numbers. So the height in this specific shape, the trapezoid, what is it? It is not 12, okay? Students sometimes say isn't it 12, Neil? No, height literally means, kind of think of it as your height. From your toes, let's say you're a human being, from your toes all the way to your head. It is vertically from up and down. It should have no slant, no nothing. That's why they symbolize it like this. They might have symbolized it in a different way. They would have given you probably a marker here saying 10, right? Whatever way they is, you're always looking from the top to the bottom. Some way, somehow, they're going to indicate the height for you. So that's why we put 10 there. Okay, what about my base 1 and base 2? The trapezoid in particular is unique because it has two bases, base 1, base 2, or base 1, base 2. It doesn't really matter. Just as long as you know that one and that one needs to go in this area there. So 11 and 16. I should make the 10 into a different number too, or color. Boom. What do you think you're going to do now? Could you guess? You're going to solve, right? Are you going to solve by hand? No, use your trusty old calculator, okay? That was Sicaria, my dog, by the way. Just write this whole thing, type it into the calculator, and let the calculator solve the answer for you. This is going to be the technique you do from this point forward. You're going to refer to the formula sheets. You are going to write out the formula of your figures, and then you are going to fill in the variables from that formula with whatever numbers that are in the shape, and then you are going to dump it into your calculator. 135. Boom. That's the area of this trapezoid. So how do you find areas for these two-dimensional figures? You look at the formula sheet, right? The perimeter is a easy one. You just add up all the outside. That's the fancy trick, right? The area of the two-dimensional figures, it's refer to the formula sheets. So I just want to very quickly, because I'm not going to go through each one, just very quickly go over a couple of the letters, the variables that you might come across that might confuse you. For instance, the square, what does S mean? That means side. So when they give you a square and they just give you a 3 there, all you need to do is get one side, which they happen to give you a 3, throw it in, square it, and that'll give you the area of the square. Rectangle, LW, that means length times width. So you got to get the length, you got to get the width, multiply them with each other. Parallelogram, base times height. That just means get the bottom length plus the height. So they might give you like, oopsie, they might give you a parallelogram like this, 10, 12, and they probably gave you the slant to try to confuse you here. They might give you 12 there, but you will be doing the parallelogram, which is the base, which is this bottom part, times the height, which is not the 12, it's always the vertical one, right? So that's how they try to trick you. So that's B, that's H, that's L, that's W, that's S. We know, and that's all you're really going to deal with, except for in the circle stage. But that is what we're going to do next. In the next lesson, we're going to be dealing with circles, specifically circles. In this worksheet after this video, you're just dealing with area and perimeter of the simplistic two-dimensional shapes. The next video, I think I'm going to make a separate video specifically to the circle, because that could be a little intimidating to throw on top of everything you just did. So just master referring to the formula sheets, of your two-dimensional figures, and master finding the perimeter as well. You got to find the area and perimeter of each figure that's on the worksheets. And just master another major important thing, which is your geometric eye. What I mean by that is, let's say I gave you this problem right here. 3, 12, 10, 6. And I ask you to find the perimeter. Well, whatever figure it is, remember, perimeter just means adding all the outside sides. So all we got to do is add 10, 12, 6, 3. But then we enter a dilemma. We don't know that side and we don't know that side. Now, if you're given a, like the example before with the trapezoid, if you are given a missing side, but they look the same, or it's not that they look the same, because they could be technically different, but if they're obviously not trying to trick you, this is a 12, right? It should match the same. It should be exactly the same. It's just one figure. There's no trickeries. These type of questions, you got to be using your geometric eye, is what I call it. And what I mean by that is you can't just assume that, oh, if this is a 3 here, it kind of looks like this measurement here. They kind of look the same, so I'm just going to put a 3 there. And you know what? I'm just going to put a 3 there. No, that's not how it rolls here. They expect you to know how to find that. How do we learn how to do that? Easy peasy, lemon squeezy. We use our geometric eye. We need to learn the technique of taking advantage of all the other measurements that we're given. So if they give us a 10 here, from here all the way down there, if I know it's 10 inches, 10 feet, whatever the unit is, it doesn't matter. If I know that's 10, it's going to be the same on this side. From here to there is 10, obviously, right? And if I take this measurement too, if I know from there to there is 6, what's the remainder here? So I had to do a little operation. All I have to do is 10 minus 6, and that'll give me my remainder here of 4, right? Because 4 plus 6 will give me that full length of 10. That is how I know this measurement here is 4. That's using geometry, your geometric eye. You guys got to be aware of that, all right? For problems exactly like this on the GD, they could give you this type of figure and then ask you what's the perimeter of it. In fact, some students have come back and told me they've given a lot, like a major shape like this with a whole bunch of weird cuts and crannies, right? And they give you a whole bunch of numbers, but every now and then they give you a missing side. And they expect you to look at this measurement here. This was a 12, by the way. This measurement over here to determine what that one is. And using that same measurement to determine what this missing side is, right? You got to be aware of your geometric eye. What would be the measurement of this side right there? Well. I'm going to use the same thing. If I know from here to there is 12, and I know from here to there is 3, well, 12 minus 3 will give me 9, and that would be my missing dimension 9, right? Again, because we know from here to there is 12. We know from here to there it's 3. So by default, this has to be 9, because 9 plus 3 will give me that full length of 12. Take advantage, master your geometric eye. So area and perimeter, just being aware of the geometry, the tricks that try to throw at you, and that would be your lesson for today.